Hey everyone, this is Mrs. Mueller. I'm another one of the pre-calculus teachers at Armstrong, and I'm going to take you through the notes for Unit 1, Day 1, which is functions and their properties. So grab your notebook, and this shouldn't take too long. We'll just cruise through this first lesson. All right, so first of all, a function. You guys have probably heard of functions before, but I'm going to give you a little bit more of a formal definition here. A function is where each element of the domain, which are maybe better known to you as the x's, is mapped to a unique element in the range, which you might be more familiar with as the y value. So for example, if this is our x's and this is our y's, in order for something to be a function, if you put a particular x value in, it has to go to the same y value every time. So for example, I could put a 2 in and it would go to, I don't know, let's go 3. If we put a 4 in, maybe it goes to 5. And if I put a 9 in, maybe it goes to 10. All right, so maybe this function is y equals x plus 1. Each time you put an x in, all that happens is you add 1 to it, and you're done. So that one would be a function. What would not be a function, go over here, would be if you put a 2 in, and it goes to 3, and then maybe you put a 4 in, and it goes to 7, but then maybe you put 2 in again, and this time it goes to -3. Okay, that's where we have an issue. You're not allowed to have an x value going to two different y values. Most of the time, you're not going to see it drawn like this, though. You're going to see it like this. You'll see, if you see a mapping situation like this, you'll see that 2 branching off to two different locations, like so. So that one would not be a function, because if we put the same x value in, we end up with two different y values, which would be a problem. All right, so on a graph, it's really, really easy to tell if something's a function or not. There's something called the vertical line test, and it says this. It says if you draw vertical lines through the graph and do not hit the graph twice, then the graph represents a function, okay? So for example, a function might be like a parabola, like a y equals x squared. That would be a function. Why? Because if I drew vertical lines anywhere on the graph, I'm always only hitting that graph one time. Once, 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 once. Okay? So that would represent a function. Passes the vertical line test. What would not be a function would be like a sideways parabola, like this guy. Okay? Or anything that sort of overlaps itself from top to bottom. So if I drew a vertical line, say right here, I would run into the graph 2 times. So that one is not a function because it hits twice. All right. And then moving on to just a couple examples here. Is it a function or not? So we have some x's and some y's, and I want to know, is it a function or not? So this is where this one I purposely put on here because sometimes people get confused because they see, okay, I got x's 1, 2, 3, 4, and then I got y's 2, 5, 0, 2. Oh, we have two 2's. Okay, well, be careful because in this case, I don't think it's going to be a problem. Maybe it's easier to decide if you plotted those points and then use the vertical line test. So I'm going to do that. So 1, 2 would be over 1 up 2, and then 2, 5, and then 3, 0, and then 4, 2. Okay, and don't connect the dots. Nothing says that these are connected. We were just given 4 ordered pairs. That's really all we were given. Ordered pair, ordered pair, ordered pair, ordered pair. Nothing says to connect them, so don't connect them. Okay, we'll now check with the vertical line test. If we go here, we only hit once, 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 and once. So we're good. This one is a function. it passes the vertical line test. Okay, now the reason why the 2 2s were okay is because they're in the range. It's okay if you have the same number multiple times in the range and it didn't necessarily come from the same number in the domain. That's okay. 1 always went to 2, 2 always went to 5, 3 always went to 0, 4 always went to 2. It'd become an issue if we put like, you know, a 1 in again and it went to something else besides 2. Maybe it went to 0. Okay, well now that would be an issue. And that would show up again on the vertical line test because we would be here and then it would fail. Hopefully that's making sense. All right, next one. Example 2, is this one a function? So maybe you're getting a little better now. Maybe you can decide without the graph if it is or not. I'll do it both ways. But this time you can see that 1 goes to 4, but then 1 also goes to 2. And that's obviously a problem. So if you were to graph those ordered pairs, you would have 1 4 and 1 2. And that's a problem. Fails the vertical line test. So that one is not a function. All right, example 3, we're going to go to an equation, y equals x squared. Maybe you're familiar with that one, maybe you're not. If you're not, if you don't just already know what that graph looks like, we could try a couple numbers. So we could try 0. If you put 0 in, put 0 in for x, 0 squared is still 0. So 0, 0. If you put 1 in, 1 squared, 1 times 1, still 1. Put 2 in, 2 squared is 4. Let's try something on the negative side. Negative 1. Negative 1, oops, put that in the wrong spot. Negative 1 squared, negative 1 times negative 1 is positive 1. Negative 2 squared is positive 4. I know you guys already know that, but we're just coming off of summer, so do it that way. All right, 0, 0, 1, 1, 2, 4. Negative 1, 1. Negative 2, 4. Okay, so y equals x squared looks something like that, and that one is a function. It passes the vertical line test, so yes, y equals x squared is a function. All right, what if we did it this way? What if we did x equals y squared? What if we did x equals y squared? How are we going to do that? Well, we could just try some numbers in the y. That would work, I guess. So if we put 0 in, 0 squared is 0. If we put 1 in, 1 squared is 1. Let's try negative 1. If we put negative 1 in for y, negative 1 squared is positive 1. Uh-oh. We can see that that's a problem now. Because when x is 1, it's mapped to 1. But when x is 1 here, it's mapped to negative 1, and that's an issue. And if it helps you to see it better on the graph, do it that way. 0, 0, 1, 1, 1, negative 1. Uh-oh. Fails the vertical line test. So this one is not a function. All right, domain and range. Domain and range is one of those things that it sometimes is almost so easy that students get confused by it. I'm just going to say it the easiest way first. Domain is how far your graph goes left to right. How far left does it go? How far right does it go? That's your domain, okay? So if you're thinking about a graph, here's a graph. Your left and right is your x direction, okay? So in other words, your domain is your possible x values, okay? Or sometimes people will call x values inputs. So possible inputs. What are you allowed to put into your function? All right. And then range, you guys are smart people, so you can probably fill in the blanks here. Range is the other direction. It's your up and down. It's your possible y values. It's your possible outputs. All right, so let's look at, put a y there. Let's look at a couple examples here. So you'll want to sketch these in your notes the best that you can. And it says find the domain and range of each function. Okay, so one more thing that you've seen before, but maybe we should talk about really quick. Closed dot, there's a closed dot on that graph. That means it touches. All right, so it means that it includes. So we would use like a greater than or less than or equal sign, or a greater than or equal sign. Okay, so it touches, so we put the line underneath. I'm gonna get rid of this actually. That's gonna be confusing. All right, an open dot means it does not touch. Okay, so it gets really close to, but it doesn't hit it. So you would not use the line underneath. We'll do it that way. Okay. Sometimes too, you might see interval notation. That is where we just use brackets. I'll do a couple examples like that. So if you have a closed dot, you will use a square bracket with a comma between it. And if you do not touch, you use regular parentheses. All right, I'll show you what that looks like. Okay, so for this first graph, I actually like to, when they're fully on the graph like this, I like to just draw a square around the whole entire thing. I think that helps. Helps you see it a little better, okay? So all of this stuff out here, you don't have to scratch that out if you want, but you can. The graph doesn't touch any of that. The furthest left our graph ever goes is right here to -3. So I'm going to write that down. Okay. The furthest right it ever goes is to 4. Now remember, it doesn't quite touch 4, but it gets really, really close. So we'll write down 4. Okay. This is domain we're talking about. So I'm going to put a D so we don't forget. Domain has to do with your x's, your left and right. And then we just do this. It touches -3. It does not touch -4, but it gets very close. Okay, so that's one good way to write to write the domain. X is greater than or equal to -3, but less than 4. Furthest left it gets is -3. Furthest right it gets is almost to 4. Okay, now with that interval notation thing, you could also write it like this. You'll still write -3 and 4, but this time you just put a comma between them. Okay, it hits -3, so you'll use a square bracket. It doesn't hit 4, so you use a curly bracket. Okay, you can write it either way you want. Most students will probably end up writing it that way because they're more familiar with that, but you're allowed to write your domain and range either way. All right, and then for range, let's just do the same thing, except bottom to top. So lowest it ever gets is 2, and it does touch. It's closed right there. So lowest it gets is 2, and highest it gets is 3. Sorry, that's a -2. So we would -2 to +3. These are y values. Touches on bottom, touches on top. So all of our y's, our domain, all of our outputs are between -2 and 3, touching both of them. Interval notation, both of these would be square brackets, and you would just do -2, 3. Okay, let's try example 6. It's a little bit different. This one, the furthest left it ever gets is -4. But the furthest right it gets, because we have this arrow that's pointing towards the right, the furthest right we ever get is infinity, right? So it's kind of weird. I guess, technically you could do this. That would be fine, but that's sort of weird. We don't usually do it that way. Usually you would just say, this would be okay. What would be better? You would just say x is greater than or equal to -4, right? Smallest it gets is 4, but it gets bigger than that. X is greater than or equal to -4. If you wanted to use the interval notation, you would actually use the infinity as your upper bound, as your right-hand side, and then you can't actually touch infinity, so you would use the regular parentheses. And then for range, see if we got the hang of this. The lowest it ever goes is right here at -3. So basically that tells us that our y's are always greater than -3. The arrow tells us it's going up forever. So we would just say y is greater than or equal to -3. Or in interval notation, -3 comma infinity. Hopefully that's making sense. All right, so what you guys need to do is grab the Unit 1 Day 1 worksheet. You should get that done by Monday so that you don't fall behind on the first day, but it probably won't be collected until test day. So just keep your stuff organized, find a folder, and then we'll get all that collected at the end of the unit.